Priyanka Singh. Today we will be discussing about the importance of hypothesis testing in data science. This is a video in continuation with our 3 previous videos which are related to the importance of statistics in data science. So let's proceed further. As Ronaldo said, torture the data and it will confess to anything. Well, I guess it's true. Here the man is also trying and tied the data very intangly, and he's trying to reveal some insights. But to reveal those confession of data, hypothesis testing could be used to interpret and draw conclusions about the population using sample data. A hypothesis testing helps in making a decision so as to which mutually exclusive statements about the population is best supported by the sample data. In conclusion, hypothesis testing is the way in which your sample data represents your population, and with the help of this testing we determine whether the sample data is best suited for population or not. Now let's see the terminologies used for hypothesis testing. Moving ahead. So here is the first terminology, that is null hypothesis. Basically, it is the commonly accepted or a general fact about any population. Let us see our H0, which is our null hypothesis, states that the mean of two populations is same, that is mu1 is equals to mu2. In real world problem, let us see example that there are two breeds, that is a breed for chicken. So first one is male and another one is female. So as per our null hypothesis, we can consider that the average food size of male chicken is equal to average food size of female chicken. This is the most ideal condition, correct? Now moving ahead, we have alternative hypothesis, that is denoted by H1 or HA. Basically, null hypothesis and your alternate hypothesis are mutually exclusive statements. Both are independent of each other. So, if the null hypothesis is commonly accepted facts, then the alternate hypothesis is a real fact based on the observation or a sample data. So here let's see an example that H1 equals to mu1 is not equals to mu2, because in real world the two population cannot have the same mean. As good as the average food size of male chicken, we generally assume it to be greater than the average food size of female chicken. Now let's see another terminology, that is critical region. The critical region is defined as the region of values in the distribution that leads to the rejection of your null hypothesis at some given probability level. First of all, we need to understand the distribution of your data. After that, there is some probability level across that graph where null hypothesis will be rejected. So, the area under that curve is referred to as critical region. Now there are two types of test for any hypothesis testing, that is one-tailed test and another one is two-tailed test. One-tailed test is a statistical hypothesis test in which the critical area of distribution is either greater than or less than a certain value, but it cannot be both. For this, the alternative hypothesis formulation, we can proceed like H1 denotes mu1 is greater than mu2, or H1 denotes mu1 is less than mu2. In two-tailed test, it is a test in which the critical area of distribution is on both the side of your mean. We assume, let us consider if a normal distribution is there. We have already discussed in our previous lecture what normal distribution is. So the mu is at the center, that is mean is at the center. So on both sides of the center, we have those critical region. It tests whether the sample means of two or more than two populations are unequal. For this alternate hypothesis, the formulation is H1 is mu1 not equals to mu2. In either of the above two tests, if the sample test falls in the critical region, then alternate hypothesis holds to be true and our null hypothesis will be rejected. The alternate hypothesis is made as a conclusive observation for the population based on the sample data that we have collected. Now let's see an example like a graph where we are seeing right tail test. For example, in right tail test, the critical region, this is our critical region, it lies at your on the right side of the mean. Whereas if we say a left tail test, the critical region lies on the left side of the mean. This is your O is your mean. On similar lines, the two tail test, the HA, that is your alternate hypothesis, lies on the critical region on both sides of the mean, on left side as well as on right side. But we all know that nothing comes with perfection, and so does data insights. And if we consider real-time data, that's too errorless, and there are lots of error in it. So if everything is perfect and with 100% accuracy, then it is something very fishy. Either the data is overfitted or manipulated. So there are different types of error that are associated with your hypothesis testing as well. So first type of error that we encounter is type 1 error. This is basically we reject the null hypothesis even when it's true. Now type 2 error, we fail to reject the null hypothesis although it is false. So basically it is a kind of true positive and false positive. Another type of error is level of significance. Basically it is the probability of making type 1 error and is denoted by alpha. In general, we consider the value of alpha, that is your significance level, as 0.05. This means that there is 5% probability of making type 1 error, that is you accept the null hypothesis even though when it is true. Okay, moving ahead, there is another type of error, that is p-value. It is a statistical concept that is used from hypothesis testing to regression and to many of tree models and such kind of structures. If the p-value is high, that denotes your null hypothesis is true. Whereas if the p-value is low, it is more likely to reject the null hypothesis. The standard p-value is equal to alpha, that is 0.05, and is used for checking statistical p-value against it and making the decision. The conclusion drawn out of it is if your test case is greater than the p-value, then we will reject our null hypothesis, else we will accept your null hypothesis. Now let's see an example. So this is example. Now I'll explain with the marker. For example, let's see this area, this is the example. For example, in null hypothesis, that is H0, we denote mu equals to 7000 for any random population. Now for H1, that is our alternate hypothesis, we assume that mu is not equals to 7000. Basically, it is a two-way testing. So binomial distribution, we have already discussed that almost all of the problems in real world falls under normal distribution curve. So the normal distribution variable is denoted by Z. Now mu equals to 0 falls on the center. We see the critical region falls on both the sides, that is here as well as here. So this is Z alpha by 2, because Z alpha we will be considered when we are taking one-sided test, either on right side or left side. But since it's a two-way test, we have taken Z alpha by 2 on both of the sides. So here Z minus alpha by 2 is 1 minus 1.96 and Z alpha by 2 equals to 1.96. Now when we will reject, as I have already discussed, if your test case value is greater than p value, that is a 0.05 by 2. Since after calculating this value, it comes out to be 1.68, that is less than 1.96. So we have accepted Z0. But if this value is greater than 1.96, that it falls in this curve or this region, we must have rejected H0. Now let's see how to use it in making business decision. So there are some steps which you should follow while testing hypothesis. So first one is formulate your null and alternative hypothesis. Another one is based on the data and probability distribution, select the hypothesis test which you need to be performed. Distribution can be a normal, uniform or any other distribution that fits your data model. Another one is based on the business and your problem statement, select the level of significance. Basically take it as 0.05. Calculate test statistic on the sample data collected. So as per the distribution, you have to form your equation and then solve your test case by putting the values in those equation and get your value. Now calculate the p-value also. Based on p-value, draw insights whether to reject or fail to reject the null hypothesis. Draw your business conclusion and bingo, you're done. So if you perform all this step in a very sequential manner, then we can have a business decision that could be made in no time and with a lot of precision and accuracy. Now let's see an example. For example, if you want to predict whether a employee with a certain resources can perform such workload or more workload, so kind of this type of decision can be made with the help of null hypothesis. So that's all for the today. Please do like, comment and share our video and don't forget to subscribe. Also, I hope this article has given you a kickstart in understanding the hypothesis testing and its importance. Thank you for watching.